Today, I want to share the framework our team uses to reduce the complexity on configuring GKE. We've built our entire infrastructure around the three pillars: automation, scalability, and security. For traditional GKE cluster configuration, I have some real-world example that I want to show here. A typical GKE cluster will need the network setup, cluster-level configuration, and node pool setup. This is a lot of code to maintain. Now I want to show you exactly how we use Autopilot. Take a look at the snippet on the screen. This could be an entire cluster definition. To enable Autopilot, just set the flag enable Autopilot equals to true. This way, we're effectively handing the operational overhead to Google. This single flag replaces those hundreds of lines of standard GKE configuration we just saw. This is the difference between building a car from scratch and just getting in and driving forward. This leads us to the second point, zero node management. Notice that there isn't a single node pool resource in this file. There's no scaling logic, there's no configuration for OS patching. Because we moved to the Autopilot, we no longer manage the infrastructure, we manage the application. We tell Google what our application needs, and the infrastructure changes to meet that demand behind the scene. Finally, the Autopilot is scaled by default. Notice the workload identity config at the bottom. In Autopilot, workload identity is native, expected way to handle security. We move from a complex configuration that requires constant maintenance to less than 20 lines of code that is secure, scalable, and ready for production. Now, let's look at how we scale our application. For maintaining scalability, we have proactive scaling. Think about it. A deployment is consuming telemetry logs from PubSub. If workers are processing a massive spike in logs and their CPU finally hit 80%, the PubSub queue is likely already backed up by thousands of messages. You are already behind. So we're reacting to the stress of the work rather than the work itself. To solve this, we use external metrics. If you look at the YAML on the screen, we aren't looking at the pod's value anymore. We're looking directly at the PubSub subscription, especially the number of undelivered messages. Our strategy here is to scale based on the queue size. By targeting an average value of 100, we are telling GKE, hey, I want one pod for every 100 messages within the pipe. The replica will start growing the moment the backlog increases, often before the existing pods even break a sweat. This is a shift from being reactive to being proactive. Ensure our data stay fresh and our hunters stay informed. Now let's talk about how we secure our cluster using network isolation. First, we focus on the elimination of the public attack surfaces. In a standard configuration, nodes often have public IPs. We don't do that. Our nodes are provisioned without any public IP whatsoever. It is a simple philosophy. If a bad actor cannot see the node from the internet, they cannot attack from the internet. Second, we ensure the internal VPC routing because our clusters are private. All communications stay entirely within the internal network. We are never going out to the open world just to manage our infrastructure. This keeps our traffic latency low and security posture high. Finally, our applications still need to reach out for public threat intelligence endpoints or external APIs. We handle this through control egress via CloudNet. Think of this as a one-way mirror. Our workload can see out and get exactly what we need to function, but the outside world has no way in. For us at Palo Alto Networks, this setup isn't just a nice to have. It is the fundamental how we compose secure system at scale. Thank you.